Hello, in this tutorial we will undertake a rigorous time series analysis to forecast sales volume. Our objective is to construct a SARIMA model or seasonal or autogressive integrated moving average model to predict future demand based on historical patterns. So we begin by establishing our computation and environment. So import pandas as PD. And then we import pandas for we import pandas for the data manipulation, matplotlib for visualization, and the pmdarima library, which is essential for our automated hyperparameter optimization. So let us load the dataset sales CSV. EF equal to and then yun. And then so examining the head of data frame, we observe the two variables. The period shows a stamp time representing the month, and the sales quantity is our endogenous target variable. Notice the nature of the data. It appears to be monthly aggregation. This frequency is a critical structural parameter implying a potential periodicity or of 12. Looking at the DF info, we have 64 observations. While this is a relatively small dataset spanning roughly 5 years, it is sufficient for univariate modeling provided the signal to noise ratio is strong. So before any modeling occurs, we strictly partition our data. And then type 0.8. Validation set. So we apply an 80-20 split. The first 80% is our training set, approximately 51 months. The remaining 20% is our validation set. In academic forecasting, we never shuffle the data. We must slice strictly by time to prevent data leakage, using future information to predict the past. To select an appropriate model class, we first decompose the time series into its deterministic components, and then type from stats models seasonal. And then ayun, lumabas yung sales. So we employ the seasonal decomposition of time series method in the code. We set period is equal to 12. We are formally testing the hypothesis and that sales follow as annual cycle. Let's interpret the signals. So the graph number 1 is the raw data that's showing a clear upward with distinct repeating oscillations. And then the trend component isolates a smooth monotone. monotonic. Increase in sales volume over 5-year period. And then the third graph is it the most critical finding for model section. And then ideally this is the should differ from the white noise only by random chance with some variance but no obvious structure that would invalidate our our approach. So having confirmed both trend and seasonality, we face the model identification problem. We need to determine the optimal orders for non-seasonal and seasonal. Instead of manual trial or error, we utilize the auto-ARIMA algorithm. This algorithm performs a stepwise search to minimize the AIC or the archaic information creation. Note that we strictly define seasonal as true and M that the period as 12. So this forces the solver to consider the annual cycle. The algorithm tests various ARIMA specifications. It penalizes models that are too complex and rewards those that fit and data well. So this is the code of the ARIMA. So the search converges the ARIMA 011 times 011 012, and then that let's analyze the specific configuration. Let's analyze. So the annual is parameter is 011. This is the non-seasonal parameter, and it applies first order differencing to remove the linear trend. It uses one moving average term to smoothing series. So the seasonal parameter is 01012. It applies seasonal differencing subtracting January 2016 from January 2015. And to remove the seasonal wave, interestingly, it found that no seasonal AR or MA terms were needed once the differencing was applied. So now we fit this optimal using stat models Sarimax. Sarima model So let's examine the econometric summary. So looking at the coefficient. Look at this the coefficient. The mole term is 0.164 and the p-value is 0.006. Since this is well below the standard alpha of 0.05, we conclude that this term is statistically significant. The moving average component is contributing real predictive power. Now look at the fit statistics. The log likelihood is negative 339.072 and the AIC is 682.143. This gives us the baseline for model comparison. So, since may code na tayo, copy na lang natin. Since may code naman na ako, kinopy ko na lang kasi medyo mahaba siya. And then, ayan na yung kinalabasan ng code natin. Yan. Sa RIMA forecast. And then, nandito na din yung result ng RMS, EMP, FE, MAE, MAPE, MPE, MSE, SSE, SMSE, MSE, and TILS U-stat is 0.34. So, yun. Thanks for watching.